So today we'll be looking at how we can use some of the large language models, including the OpenAI's API platform, as well as the Google's MakerSuite, which incorporates the Palm API, in order to use them and make an application that is useful for your case. So today we'll be looking at one application that I've worked. It's called the ClimateServ GPT that uses the ClimateServ API. I'll show more about what ClimateServ is and what it does here in a bit, but it uses that API and helps you extract some of the API parameters from the user prompts. The idea is that by allowing users to type in the free flow text, they could be more innovative with their prompts, and as a developer you can then focus most of your energy on developing these very enriched API instead of focusing a lot of your energy in the UI component. I develop many applications, the WebGIS based applications, and it takes a lot of time and energy, as well as thinking in designing the UI for this kind of application. And as you keep on adding more features onto your web platform, it starts to become more clutter, and there is room for improvement. And at some point you're basically redesigning an entire GIS system in the web, and it becomes very difficult to manage as the number of features continue on increasing. So the idea is to basically allow users to add in any of those complexities via the prompt, via the chat interface, and the API or the large language model under the hood would take that, parse the required parameters that are needed, makes the API call, and presents the users with the result. The application that I currently have is a simple proof of concept that I developed here, but you can think of this as a starting point and keep on adding newer features as it interests them. So let's start. So again, the idea is that you have some form of an UI where users can type in their query as a free flow text, and those queries will be parsed by any kind of large language model, and mostly using the auto completion for this use case. But you can use a chat kind of interface where you can have a back and forth conversation with these large language models. These large language models are the major role is to extract and translate the prompt, and give you those parameters that you needed in order to make those API calls to your backend. So the backend in this case is the ClimateServ. We'll be using the ClimateServ Python API. Once the parameters are extracted and the ClimateServ processes those API endpoint, the response would then be provided via the same user interface that we'll be developing. So let's start by going and looking at what a ClimateServ is in this case. So the ClimateServ is a service that is developed here at the Severe Science Coordination Office, Severe Global, that lets you easily visualize and download the rainfall and temperature data sets. It lets you visualize and download the forecast as well as the historic data sets on rainfall and vegetation conditions. So you can access chirps, you can access other forecast data from here. Now the current usage is from their map interface, where users can go and you can draw your area of interest, or you can even select from the list of the country kind of thing. Once you click on the map, it will select that particular country. I'm doing a time series analysis in this case for observation data sets, and I'm interested in looking at the chirps rainfall data set, average rainfall, chirps rainfall from let's go up to January of this year until the October of 31st. So once you select this, you can add the query. Once you have the query, you can view the API endpoint. Sorry, I selected multiple countries here. I'm just interested in one particular country, so I'll go ahead and select it again. Now you can see the API call that it's making will also go and look at this API in a bit, but once the API call, you can see the API call that it's about to send, then you can submit your query. So once you submit your query, it goes and processes that query. It gives you this chart where it's showing you the average chirps data set from January 1st 2023 to October 31st 2023 for Nepal. So you can do all these things in the ClimateServ. You can download the data and everything over here. For this particular large language model that we'll be developing, we won't have all this full-fledged functionality, but we'll have the basic functionality in it. Now if you go to this about page, here it gives you more description of different kind of data sets that are available, chirps and MME, the weather data sets, similarly the MODIS, and several other data sets are available here. And now if you go to the help center, again more description on this data, but it also has description on this UI interface as well as the developer API. So there's a way that you can actually go and access this data programmatically. So in this case, in our particular case, we'll be using this developer API interface to do basically what we saw before. They also have the PyPI project that you can go and easily install using a pip. If you're using pandas, similarly also the Anaconda, it's also available through Anaconda, so you can also use the Conda interface to download the dataset. For this GPT tool is available here. You can go to this particular repo and you can start cloning it. It has all the requirements that you need in order to set this up locally. It's very simple tool. So I have gone ahead and clone the repository, made a new Conda environment, clone the repository, and then install all the requirements that needed to run this particular tool. So let me go ahead and open that up here. So this is sort of the overall tool that you can see. And before we start using this, you'll see here there's two. You'll in the beginning you'll see the .env.example. You can go ahead and copy that and rename that to .env. So it will use your API key from here to access the application. We'll see how we can generate that API key here just in a minute. But once you have clone the repository, you can copy this environment file rename that to just have .env, and that's the particular file that these scripts will be using on. So let's go ahead and look at generating those API file. In this case, we'll be looking at the the OpenAI playground. It's what it's called. So if you go and click the OpenAI platform, if you have subscribed, you should be able to access this. Again, as I mentioned, I'm using autocomplete model in this case. This is sort of a legacy model. You can also use a chat kind of interface, so you could have a back and forth kind of interaction with your model, but the idea with prompting and everything would be same whether you use the autocomplete or a chat interface. So the main thing that drives this large language model is how well you're able to articulate your problem statement to them. That is, how well you can write the prompts, how well you can provide examples to them. That way they know what to expect and what to learn, and then would give you the results that you are expecting. So in our case, if I go back and look at this UI ChatGPT, you'll see here's the instruction that I have put together in order for this ChatGPT tool to go and extract from. So I'll go ahead and pull that here. In fact, I've saved them as a ClimateServ here. So I'm telling it that I want it to extract 5 pieces of information from the prompt. I want it to extract the data set type and reducer type, start date and end date, and these are 4, and the 5th value is the bounding box over here, which I've described in a little bit more detail. But the start date and end date needs to be formatted in this particular format. Similarly, for the dataset type as well as the reducer type, I have sort of this lookup table created, so it would give me the exact parameter value that is needed by the ClimateServ API. And I'm getting these values from the ClimateServ Developers API, where they provide you the list of different kind of data sets. Similarly, the parameter types, mean, max, range, average, all these kind of parameter types that the ClimateServ supports. So in case of the dataset type, there's the MODIS dataset type for Central Asia, West Africa, East Africa, South America, IMERS data type, IMERS early, chirps, and all these data types are provided as a dictionary over here. For the reducer type, I have average, mean, max, and all these kind of things that I anticipate that user would type. And the last value is the bounding box that is needed. So here I've described that this is the 5th value is the bounding box, which represents the bounding box represented as an array of 5 arrays. So it's a list where each of these inner array represents a comma separated latitude and longitude in WGS 84 with up to 5 decimal places. And then I've gone and described what those coordinate points are. These are the coordinates of the top left, top right, bottom right, bottom left, and top left corner. So starts from the top left, goes to the top right, bottom left, and then the top left again. And I want the LLM to extract those from the prompt itself. And finally, I want it to return all these 5 values separated by a comma. And I've also gone ahead and given it some sample prompts here. So example prompts include, what is the maximum rainfall for Cambodia for first half of 2020? And the response should be a CHIRPS data set. If we have multiple precipitation value, we can also tune it to extract the other precipitation types or precipitation data set. But in this case, I wanted to extract the CHIRPS. It's a maximum, so max is the reducer type in this case. First half of 2020 would be January 1st 2020 to June 30, end of June 2020, and then these are the bounding box. Similarly, the next example I have here is, what is the average Central Asia E-MODIS? Again, it's not very user friendly in the sense that you need to be able to remember what the different data type is, but you can improve this. Again, this is just a proof of concept, and you can find different innovative ways in order to make it much simpler for your large language model, so it can do those kind of mapping very easily. But in this case, I have here, what is the average Central Asia MODIS value between 2018 January 3 to 2018 March 16 for Kenya, and this is the response that I'm expecting. Similarly, the last prompt that I've shown here is the mean SMAP value for Vietnam for the first quarter of 2019, and this is the response I have. And now I've gone ahead and, let me quickly remove this, and given it a new prompt. The prompt here is, what is the maximum rainfall for Cambodia for first half of 2020? And I go ahead and submit that. It would go ahead and, based on the examples and the lookup table that it has seen, and the prompt that I have provided, it gives me this comma separated 5 values. The first is the dataset type, which is CHIRPS in this case, maximum, so max in this case. The start date and end date are formatted correctly as we see here, and then the bounding box is also shown here. Again, this is sort of the same example that we have here, but I can go ahead and I can type in other example. For example, what is the median, let's say I wanna know more about the temperature for let's say I wanna know about the Bangladesh for let's say the next one, I would say monsoon of 2018. So if I go ahead and type this and submit that, it would go ahead and it knows that we're looking at the temperature. This is the median value. Monsoon would be June to August, September here. And then here's the bounding box that it's providing me. So now the ClimateServ I can provide these parameters to the ClimateServ API, and that would give back the result. So this is sort of the prompting that you can do in their playground itself, but you'd also need these. I'll go ahead and save this for now. I'm gonna go ahead and update that. You'd also need the API keys in order to access them. So I have several APIs, but you can go ahead and do demo API, and you can create that secret key. So once you have that secret key, you can copy that. You can come here, you can paste your ChatGPT secret key over here, and then you're done. So once you're done, you can go ahead and you can revoke that, delete that, so that other people couldn't use it. Yeah, so this is with the OpenAI ChatGPT interface. Google also has their own version of this called as the MakerSuite. So if you go ahead and type MakerSuite in there, there's also a similar concept of where you can provide the text prompt, a data prompt, or a chat prompt. In this case, I'm gonna use the text prompt. So if you go ahead, you can go and create this text prompt. In this case, I already have those text prompt. It's the same text prompt that I've used in the ClimateServ, the OpenAI one. Again, providing it the same instruction and and then at the end I'll provide the prompt. I'm just curious here to see how well these two compare with each other. So I'll provide the same prompt here and then let it run. So temperature median, okay, monsoon, the dates are same, which is good. But if you look at this bounding box, this is the biggest issue I have found, is that the bounding box would be very different from one another. So I kind of feel like this is in the ballpark range. 8820 is somewhere there, but here you'll see that 2226. So I kind of feel like this is probably outside, but we'll have to go and check where that would be. I'm at the Google Earth Engine code editor, and I've gone ahead and copy pasted these coordinates both from Palm API, MakerSuite, as well as from the ChatGPT. So here are two coordinates. Let me go and create the geometry. Call this geometry Palm. The Palm one. Then next I'm gonna create the one from the ChatGPT. Go and let's visualize the from the Palm API, then the one coming from the ChatGPT, and if we run this, okay, so as you can see, this probably is from the GPT. If we toggle on and off, it's in Bangladesh, but it doesn't cover the entire country. And here the one from the bird or the Palm GPT is somewhere here in Libya and Egypt. So there are some issues with generating the bounding box. I haven't found them to be very accurate, but this is what we get. And then there are different models that you could try. I have the Text DaVinci 003, which is the most accurate of the ones they have over here. This sign over here signifies how accurate these are, or how powerful these are. So this is the most powerful and accurate one. Again, this is the legacy one. You can do similar things with your chat API. And then the other thing that that you need to be aware is this temperature parameter. So the temperature, it controls the randomness. The lower value means that you'll get the less random result. That means if you want to have same result consistent throughout, you could have the lower number. I have 0.25 in this case. You can even have it very less. Similar thing exists here. The only model that's available here is the text Bison, and then I have a very low parameter, low temperature setup here as well. So this is the way you could set up these prompt that then you can use in your programming interface. So I'm gonna go and save this. And the good thing with the MakerSuite is that you can get your code from here, so you can get different kind of API endpoints. It will give you the basic syntax of how you can use this in your application. So you can just copy paste this. It's the same thing I have done. It also gives you the collab here. If you go and look at this in the script that we have used here, so for this I'm using this library called the Gradio. Gradio lets you make this interface for your application. It's very easy to use. It has this chat kind of interface and several other things. So here's a simple example of using a hello world. Just gives you hello world in this case, but it's a very powerful way to create machine learning apps that then you can share. So we're using Gradio in this case, and this is the ChatGPT one. Basically everything here is same with the MakerSuite one, just the way the API are consumed. MakerSuite gave us those API that I'm using here directly. So the request data, which is, again, if you go and look at them here, these are the data. All these things are utilized here, and then you use this Palm Python module to get the response based on your request data and the prompt that is provided. So prompt in this case is the thing that we pasted over there in the playground, and then with the Gradio you have those boxes where the user would type their free flow text, which goes after this. And then you get the response from there. You parse the response. Once you parse the response, you get all these request data, which is basically the data set type, reducer type, start date, end date, your bounding box, the ensemble value. So there are also several other parameters associated with the ClimateServ. The ensemble, that's mostly useful for the forecast variable. For now, for this demo purpose, we don't have any of those options enabled, so I've done seasonal ensemble as false. That means there won't be any seasonal variables, and I've just provided this LLM as true, so that the ClimateServ team who are developing these would know that this request is coming from the large language model. And then once the request data are assembled, then it goes and make the call, which is a very simple call. In this case, I'm using the ClimateServ Python API, and I use the .api.request data method, and from there I get the response back, the output one. The output is requested back, which is then used to construct the basically construct the plot that you're seeing in the earlier version as well, in the web interface as well. So if I go, so it's the same thing with the chat GPT also. With this we use their endpoint, insert the API key, the instructions, and then it concatenates the user prompt after this, makes the ClimateServ call, and make a plot for this. So if we go and open my terminal and activate my Conda environment and go inside the repository where this is hosted. Okay, so now I'm inside this repository. So the easiest way to run this would be just to Python UI chat GPT, and remember I only have the correct API key for the chat GPT, so this would work for this moment. So if I go and run this, it will it's running locally now, but it says you can also create a public link by setting the CR equals to true in the launch, which is basically a method that is called once you construct all the interfaces. So the Gradio gives you a simple way to construct the interface with your input, outputs. You can also set some examples, title, description. You can also have your own CSS to modify, beautify the thing. Okay, so let's now go ahead and copy this link and paste it over here. So this is the interface that we can see now. This is built with Gradio. I have some examples set up here. Yeah, we can just try one of the example. So when you go and hit the run, what's happening, it's going and getting the it's using that prompt with the already provided instructions, and this is the request data it's constructing at the end. Dataset type, reducer type, start date, end date, bounding box, seasonal ensemble, seasonal variable, LLM. It's then requesting that to the ClimateServ API, which is processing the request and getting us the data back in a CSV format, which is then presented over here. So this is the simple example for running or constructing your own application using the large language model APIs that you can do yourself. Not a great result in this case here. I'm looking at the maximum rainfall for Cambodia for first half of 2020. Yeah, and that's all I have for today. I'll see you in the next one.